Algebra 2 10.5b, we're still in Chapter 10, and this is about parabolas. We're going to find the vertex, focus, directrix graph by completing the square. Remember, there's a link in this video's description so that you can just click on any previous ones you may have missed. So we're going to have our theorem right up front, okay? If a parabola is translated so that its vertex is the point HK for x and y, and its axis line of symmetry is parallel to the y-axis, it has this equation. So its line of symmetry, that's what's cutting right through it, right? If that's parallel to the y-axis, so y would be here, it's parallel to it, it has this equation, the square of x minus h equals 4p times y minus k. This is where the focus is h and k plus p, whatever that p is. And the directrix is y equals k minus p. So it'd be this k minus that p, all right? Now, check how this switches around. Now, this is if it's parallel to the y-axis, okay? If a parabola is translated so that its vertex is hk and its axis line of symmetry is parallel to the x-axis, now it's going this way. It has this equation. So instead of x, the square of x minus h, we have the square of y minus k. See how they switched? They swapped places, okay? And it's going to equal 4p times x minus h. Now look at the difference of the focus. Here it was h and then k plus p. Here it's h plus p and then k. And the directrix went from y equals k minus p to x equals h minus p. See that? So this side is showing you this side. See that? All right, so that's our theorem. So we can find the vertex, focus, and directrix, and then draw a graph for the parabola x squared plus 6x plus 4y plus 5 equals 0. We're going to set it so the x variables are on this side and the y variables are on this side. See that? Plus the constant. So we're going to add a negative 4y and negative 5 to each side of the equation so that it is balanced like that. And then when we complete the square, 6 divided by 2 is a 3. We square it, so we have a plus 9 on this side. And because we added a plus 9 on this side, we have to keep it balanced. So we're going to add a plus 9 on this side. And negative 5 plus 9 is a 4. So now this is what we have. And we can factor this as the square of x plus 3. And we have a x minus h, don't we? So we can't have a plus there, so we set it as x minus a negative 3. See that? Inside the parentheses. And we need a y minus k on this side, so we can say 4 times a negative 1 times y minus 1. That tells us our vertex is a negative 3 and a 1, and our focus has to follow this h and then a k plus p. So we've got a negative 3, and then our k is a 1 plus the negative 1. Well, that gives us a negative 3 and a 0. The directrix is y equals k minus p, so we have y equals 1 minus a negative 1. Well, that's going to equal a 2. We add the opposite, right? So we end up with this as our graph. Here's x equals negative 3. That's our line of symmetry, our axis of symmetry. The vertex is at negative 3, 1. Our focus is at negative 3, 0. Y equals a 2. See that? All right. Let's try it again. We can find the vertex, focus, and directrix and graph the parabola. Now it starts with a y squared plus 6y minus 8x minus 31 equals 0. We can add an 8x and a 31 to each side of the equation. We complete the square. 6 divided by 2 is a 3. Squared it. We have a 9, so we're going to add 9. So we add 9 to that side of the equation. We combine the 31 and the 9, and we get a 40. We can factor this as the square of y plus 3 equals 8x plus 40 on this side. we need it to be set to a subtraction sign, so we can say y minus a negative 3 inside the parentheses. This can be factored as 8 times x plus 5. That's going to give us a 4 times 2 for the 8, and this has to be a negative, so we have x minus a negative 5. So we're putting it in the same form as the theorem. Our vertex is negative 5, negative 3. Our focus is negative 5 plus 2. So remember, the focus is h plus p, and then the k. So since p is 2, we have negative 5 plus 2. And then we have our negative 3. So that's going to give us a negative 3 for our focus, which is right there. The directrix is x equals h minus p. So we've got a negative 5 minus 2. That's going to give us a negative 7. We can take a look at our graph here. Here's x is negative 7. Y is negative 3. Here's our vertex at negative 5, negative 3. And here's our focus at negative 3, negative 3. So just remember that HK represents the vertex for a standard parabola. Now for any equation in x and y, if x is replaced by x minus h and y is replaced by y minus k, then the graph of the new equation is the original equation shifted h units in the x direction and k units in the y direction from the origin. So here's the origin, and it got shifted. See that? Got shifted over. Okay? Our next video, 10.5c, we're going to talk about parabolas and how to find equations from given characteristics. I'm going to add this to the Algebra II playlist. There'll be links to those previous 17 videos in the description, so you can just click on them. All right? So I hope you're having a great day. I'd like you to keep trying. I'm really proud of you. I'll see you next video. Bye.